Hello friends, welcome back to Beyond Pipelines, lecture 106 on Poisson stress in buried pipelines. I've already explained you about the combined stresses in buried pipelines, in which Poisson stress takes part in the buried pipeline net longitudinal stress, as the main contributor, one of the key contributor. And some of my friends, while discussing with them, friends and colleagues, they told me that you try to explain the Poisson stress, Poisson's theory, because there is a lot of misunderstanding in the market about what is Poisson stress. Some people think that it is 30% of hoop stress because the line is buried and there is a soil cover acting on it, soil weight acting on it. But all these misnomers, misunderstandings, I just wanted to, kind of avoid, from remove from people's mind. So let us see what exactly is the Poisson's theory. So the I have made this schematic, some kind of a scheme in which I have shown one buried pipe. This is a ground level, and there is a sand or soil cover. Yeah. This is pipe of diameter D and length L. This is just one section considered for the explanation. There is a internal pressure P acting in the pipeline in all directions internally, because of which the pipe is supposed to expand or enlarge in the diameter. The pipe has got fixed mass, it has got fixed diameter and fixed thickness. So when the pressure is going to act, which is going to create hoop stress in the pipe, there will be the pipe will try to expand, and for expansion to accommodate, there is a fixed mass in the pipe, therefore its length is try to reduce. Okay, the pipe will reduce in the length. So it is shown that original diameter and enlarged diameter after the pressure acts, and this is the original pipe length, and it shrinks or it reduces in the length along the axial direction as radially it expands. Okay, so this proportion of the radial expansion and the axial reduction of length is called Poisson's ratio, and this is what is considered as a Poisson stress. Now, if this pipe is kept above ground, when there is no soil weight acting, okay, then there is no resistance to the axial movement of the pipe, and therefore the stresses won't come in the picture. But because the pipe is buried, as shown here, there is a soil cover on it, the weight is acting, there is a friction between soil and pipe. So because of that, when due to internal pressure, the diameter tends to increase and length tends to reduce, the axial displacement which is required for the length to reduce is resisted by the soil weight and the friction factor, and that creates the stress which is called Poisson stress, and that is normally considered as 30% of the radial stress. So 30% of hoop stress, as I have already explained in my earlier lectures, is PD by 2T, which is called SH, and this is 30% of hoop stress. It acts in the only for the buried pipelines. Now let us see the theoretical part of it. So Poisson's ratio is the deformation of a material perpendicular to the loading direction. Yeah, it is negative ratio of transverse strain to axial strain. So if you see, this particular case belongs to our pipeline case, which I have explained earlier. If there is a radial pressure acting and radial strain, or the lateral strain that is going to occur in the line, in the pipeline, then there will be axial strain or longitudinal strain acting in the opposite direction, which is basically the pipe length is going to reduce, and because of that there will be hoop stress acting, which is 30% of sorry, not hoop stress, the Poisson stress acting, which is going to be 30% of hoop stress. Okay, so Poisson stress is normally considered as 30% of hoop stress, and it's a definitely major contributor in the net longitudinal stress in the buried pipeline. So since we said that it is a ratio of transverse strain to axial strain, so since it is 0.3, if the axial strain is 1 unit then in the axial direction, okay, in the lateral strain is 1 unit, then axial direction it's going to be almost 3 units, so 1/3, so it is almost 0.3. So that's how the Poisson stress comes in the picture. I believe with this explanation now your understanding of Poisson stress is very clear, and why it acts only in the buried pipelines is also I have explained, not in the above ground, because there has to be a resistance for that axial movement which is offered by the weight of the soil and the friction factor.